This is an introduction to systems and phase plane analysis, and in this video we will be talking about differential operators and the elimination method for systems. So let's take a look at some operator notation for differentials. We have been pretty comfortable with this notation. Y prime of t equals dy dt equals the derivative of t, a derivative with respect to t of y. And also y double prime of t means the second derivative of y with respect to t. And of course the derivative with respect to t of the derivative with respect to t of y. So we're pretty comfortable with this notation, okay? And we want to make sure we understand that this notation says that we are operating on the function y with the differential operator d dt. So we're pretty comfortable with that. So now let's take a look at using d instead of the derivative with respect to t, that operator, okay? So now, for example, let's take a look at this second order differential equation. We can say that d squared y, which represents the second derivative, plus 4 multiplied by dy, the derivative of y, plus 3y is equal to 0. And now, as you can see, we have d squared plus 4d plus 3 of y is equal to 0. And we also interpret this d squared y, meaning the derivative of y. Okay? So, oops, and that's written right there. Okay, so let's go ahead and just try an example and jump right into this. Show that the operator d plus 1 multiplied by d plus 3, so we're just working with the operators here in the question, is also the same as d squared plus 4d plus 3. So of course, if we have a twice differentiable function, let's just go ahead and write that. Let y of t be a twice differential function, differentiable function. What we have is that d plus 1 multiplied by d plus 3 of y is going to be equal to d plus 1 multiplied by the operator d plus 3 on y. And that is equal to d plus 1 multiplied, and let's use our notation. Here's y prime plus 3y. And that is equal to now the operator d on y prime plus 3y plus 1 multiplied by y prime plus 3y. So this d, this operator on y prime, will give us y double prime plus, we'll have 3y and 3y here. Whoops. 3y and y prime, since this is the derivative. So we'll have plus 4y prime plus 3y. And that is exactly equal to d squared plus 4d plus 3 of y. Therefore, d plus 1 multiplied by d plus 3 is equal to, or is the same as, d squared plus 4d plus 3. And keep in mind that we cannot treat these as ordinary polynomials. Of course, we can if, only if, the coefficients are constants. But if we have variable constants, we cannot treat these as ordinary polynomials. Let's take a look at what happens in this next example. So of course, we are going to let y of t be a twice differentiable function. And let's go ahead and show that the operator d plus 3t times d is not the same as d times d plus 3t, that these operators are not the same. So if y of t is a twice differentiable function, we have that d plus 3t multiplied by d of y is equal to, and we're starting here with this left-hand side, d plus 3t of y prime. That's y prime. And that's equal to y double prime plus 3t y prime. So that is number one. Now, let's look at this second expression. So we have d multiplied by d plus 3t of y is equal to d of y prime plus 3t y. And this is going to be y double prime plus 3y plus 3t y prime. And these are not the same. Okay. You might want to say this happened since 3t is not a constant coefficient. Okay, let's talk about the elimination method. We're going to go ahead and solve this system, and then we're going to summarize. Let's go ahead and write these in standard form. So we have x prime of t minus 3x of t plus 4y of t is equal to 1, and y prime of t minus 4x of t minus, plus 7y of t is equal to 10t. Now we will use operator notation, and we will have that d minus 3 of x, and that's right here, d minus 3 of x, plus 4y is equal to 1. And let's write our second equation in operator form. So we will have minus 4x plus, and we're going to put these two functions together, d plus 7 of y is equal to 10t. And then we're going to multiply 4 times this first equation, and then we are going to apply d minus 3. So let me just move this over just a bit. I can actually put this 4 in the front. We're going to apply d minus 3 to this second equation. And now we are going to add these together. And as you can see, we will have this. I'll go ahead and do this in this blue pen here, you see we'll have the 4d minus 3 of x, and here's the negative 4d minus 3 of x. So adding these together will allow us to end up with 16 plus d minus 3 times d plus 7 of y and that's equal to, and of course we'll have this 4, and of course that's times 1, 4 times 1, plus we have the d minus 3 operator on 10t. And we see that this is equal to 4 plus 10 minus 30t. And let's simplify this left-hand side. So we have 16 plus d squared plus 4d minus 21, and that comes out to d squared plus 4d minus 5. Oh, and this should be of y. Minus 5 of y is equal to 14 minus 30t. So now, we have a second order linear equation. So this is second order linear equation with constant coefficients. So we can say that our auxiliary equation to the homogeneous equation would be r squared plus 4r minus 5 is equal to 0. So we have r1 equals negative 5 and r2 equals 1. So we have that homogeneous solution to the homogeneous equation. C1 e to the negative 5t plus c2 e to the t. Now let's go ahead and look at the non-homogeneous equation and use the method of undetermined coefficients. And so we have y double prime plus 4y prime minus 5y is equal to 14 minus 30t. And we have yp is equal to a1t plus a naught. And of course we have yp prime is a1 and yp double prime is 0. So putting these together, we can say that 0 plus 4a1 minus 5a1t plus a naught is equal to 14 minus 30t. So let's simplify this. 4a1 minus 5a1t minus 5a naught is equal to that. And we can see here that here are our constants. So it must be that 4a1 minus 5a naught is equal to 14. And we also have that negative 5a1 is equal to negative 30t. So a1 is equal to 6. And solving for a naught, and we come up with a naught is equal to 2. So with that, we have that y And let me put that over here to the right. Yp of t is equal to, and we had our a naught, which is 2 plus 6t. Oh, I'll go ahead and do the 6t first. And that leads us to our y of t. Our general solution is that homogeneous solution to the homogeneous equation plus our particular that we found from our undetermined coefficients method. So we have y of t is equal to c1 e to the negative 5t plus c2 e to the t plus 6t plus 2. Okay. Now the question comes up is how are we going to solve for x of t? So there's a couple ways that we can do this, but I think the easiest way is to take a look at our original equations here, and we can go ahead and solve this first equation for x of t. So let's go ahead and try that. So if we have that, we can say that negative 3x of t is equal to 1 minus, let's go ahead and solve the second equation. So we're going to solve the second equation for x of t. So we will have negative 4x of t is equal to the opposite of y prime of t minus 7y of t plus 10t. So solving for x of t, dividing each one by a negative 4, we have 1/4 y prime of t plus 7/4 y of t minus 5/2 t. So we are going to take this equation for x of t and substitute it in. So let me go ahead and type that right here and make that a little bit smaller. And then I think this here, we'll go ahead and change this to y of t. And now we have our x of t here from, and I'll go ahead and put a double star so now we can say that x of t is equal to, and we'll use that 1/4 multiplied by negative 5 c1 e to the negative 5t plus c2 e to the t plus 6. So that is our y prime plus 7/4, and now we will multiply by our y, which is c1 right here over to the left, e to the negative 5t plus c2 e to the t plus 6t plus 2. and then we still have that minus 5/2 t. This will simplify to 1/2 c1e to the negative 5t plus 2c2 e to the t plus 8t plus 5. So as you can see, this elimination procedure can get a little bit tricky, but for the most part, it's pretty straightforward. So here we are looking for polynomials in D, L1, L2, L3, and L4. And of course, D is the derivative with respect to T. We want to make sure we are in operator form. We're going to eliminate one of the variables and solve for the resulting equation. We went ahead and solved for x of t, okay? So we are not going to have any degenerate systems here. So then you can go ahead and read the shortcut. We eliminated x from the system and we solved for y of t and so forth. So you can read through that procedure. Let's take a look at this next example. We're going to find a general solution for this system. So we'll go ahead and go and write in operator form and operator notation. So we're going to have d squared minus 1 of x plus d plus 1 of y is equal to negative 1. You can see here the d for the x functions here minus 1 and the same for our y functions. Let's go ahead and write our second equation in the same manner. We have the derivative and then x, so we will have d minus 1 of x plus d of y is equal to t squared. So here you can see, let's go ahead and write that down. Here you can see that L1 is equal to d squared minus 1. L2 is equal to d plus 1. L3 here is d minus 1, and L4 is going to be equal to d. Now we are going to go ahead and show that we have a formula for doing so. So here we are going to write that L1 multiplied by L4 from this here minus L2, L3 of x is going to be equal to L4 multiplied by L4, of F1 minus L2 of this F2. Okay? We also could eliminate the variable x by using L1, L4 minus L2, L3 of x and have that equal to L1 F2 minus L3 of F1. So let's go ahead and do that down here. So as you can see, we will have, and we can rewrite those here. Let's go ahead and do that. So we have L1, L4 minus L2, L3 of x is equal to L4 of F1 minus L2 of F2. And of course you can see here that F1 is -1 and F2 is t squared. Okay, so let's go ahead and use that. So we have d squared minus 1, that's our L1, multiplied by d, minus d plus 1, that's L2, multiplied by d1, all of x is equal to, there's our L4 of -1, L4 is d, minus d plus 1, which is our L2, of t squared. Okay, we can go ahead and take a look at that. So as you can see here, we have d squared minus 1d minus d squared minus 1 of x. And the derivative of -1 is 0 minus, and let's just go ahead and put this here right now, and then we'll go ahead and take care of it on the next line. So now, as you can see, we have d squared minus 1 multiplied by d minus 1. And you can see that right here, d minus 1 of x is equal to, and then d of t squared with that negative is -2 minus, of course, we still have our t squared. Taking a closer look at this, you can see that we have d minus 1 squared multiplied by d plus 1 of x is equal to -2t minus t squared. So here we have third order dE. So we are going to expect 3 arbitrary constants in our general solution. So our corresponding homogeneous equation has, so let's look at our auxiliary equation for we have r minus 1 squared multiplied by r plus 1, which is equal to 0. So we have r equal to, r1 equal to 1, which is a double root. And we have r2 equal to -1. And that will give us xh of t equal to c1 e to the t plus c2 t e to the t plus c3 e to the -t. Now, for the particular solution, we use the method of undetermined coefficients, and we will have that particular solution equal to at squared plus bt plus c, and you can see that because of this term, this f of t, and we will be using that for our differential equation. We have r minus 1 squared multiplied by r plus 1. we have our, let's rewrite that as, I guess we'll just go ahead and keep that. And that's equal to r squared minus 2r plus 1 multiplied by r plus 1. And we have r cubed minus 2r squared plus r squared minus 2r plus 1. And we come up with, this should be an r cubed. We come up with r cubed minus r squared minus r plus 1. So that gives us x triple prime of t minus x double prime of t minus x prime of t plus x of t equal to and what do we have here? Negative 2t squared minus t squared. Negative 2t. Okay, so plugging that in, we have xp prime of t is equal to 2at plus b xp double prime of t is equal to 2a. And of course, our third derivative of that proposed solution is 0. Okay, so we will plug those in here. And as you can see, over here, we will have 0 minus 2a minus 2at minus b plus at squared plus bt plus c is equal to negative 2 minus t squared. So we can see that, and we'll go ahead and just put those together. We have at squared plus b minus 2a multiplied by t plus c minus b minus 2a is equal to negative 2t minus t squared. So it must be that a is equal to negative 1. And we have that b minus 2a is equal to negative 2. And we can plug in a is equal to negative 1 and b is equal to negative 4. And then we have c minus b minus 2a is equal to 0. So c plus 4 plus 2, plugging in a and b, gives us c is equal to negative 6. So therefore we have yp of t is equal to negative t squared minus 4t minus 6. So now we have our general solution, which is the solution of our homogeneous equation plus our particular solution, and we come up with c1 e to the t plus c2 te to the t, which we can see above, plus c3 e to the negative t, and then our particular solution. So this is our y of t. Now, we do have to look for, and oops, this was xp of t, and so now we need to go find yp of t. and how we are going to find yp of t or y of t, we are going to take this shortcut right here, okay? So we are going to take a look at these two equations above, and we are going to subtract this equation from this equation. So we are going to use 1 minus 2. And I will put a star here. Okay, so if we do that, and I can go ahead and copy these. What we have left is d squared minus d of x. You can see that these ones will cancel, negative ones will cancel, plus y, whoops, and we don't have to put that. And you can see that these d's will cancel. We'll just be left with our y is equal to negative 1 minus, since we're subtracting, t squared. Now we can go ahead and solve for y, and we can say that y is equal to, and when we subtract this term, we can go ahead and say that that is d minus d squared of x minus 1 minus t squared. So if we use this expression for x of t, in this equation, and that would be right here, we will now have that y of t is equal to c1 e to the t plus c2 t e to the t plus e to the t minus c3 e to the negative t minus 2t minus 4. You can see that right there. And then we still have to subtract c1 e to the t plus c2 t e to the t plus 2e to the t plus c3 e to the negative t minus 2. And then we still have minus 1 minus t squared. And that just simplifies to the opposite of c2 e to the t minus 2 c3 e to the negative t minus t squared minus 2t minus 3. So the x of t and the y of t we have now will give us our general solution. Did want to mention that this right here is our x prime of t, and this right here is our x double prime of t. And so then we still have this term here. So you can see where we have the derivative and then the second derivative of x and plugging that in. Okay, and that concludes this video.